ilondoloze, ilondoloze nami, ilondoloze, uhambe nami, zungangishilana, dawo yami ayikholana, buso wami awukholana, ilondoloze, zuhambe nami, dawo yami ayikholana, buso wami awukholana, ilondoloze, zuhambe nami, ilondoloze, 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 zungangishilana, ilondoloze, 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 zungangishilana, dawo yami ayikholana, buso wami awukholana, ilondoloze, zuhambe nami, dawo yami ayikholana, buso wami awukholana, ilondoloze, zuhambe nami. Jerusalema, ikhaya lami, ilondoloze, uhambe nami, zungangishilana, Jerusalema, ikhaya lami, ilondoloze, uhambe nami, zungangishilana, dawo yami ayikholana, buso wami awukholana, ilondoloze, zuhambe nami.
All right. Hello, everyone across Africa. Good afternoon. Good afternoon. My name is Donald Ajax. I will be your trainer for today's session. So, today we'll be covering Python basics for AI. Python basics for AI. This would be an introductory class to Python for you, for those who have never used Python before. Okay, so welcome, welcome, welcome. I hope you love that little song. Okay, I just play that to give time for other learners to join, for those who aren't here yet. So we have more people on board now. So yeah, let's get started. Okay. All right. So first of all, I'll just let me just jump right into it. Okay. So first of all, I'll start with an introduction to what Python is. All right, and then go deeper into what we're going to cover. Okay. So first of all, let me show you the outline so you see. Materials and the videos that were given to you. So this session is more of a summary or recap, and it also gives you a chance to have your questions answered live if you do have any questions. Yeah. So just 1 second. All right. All right. Just trying to share it, but I'm having trouble finding. Okay, there it is. All right. So this is what we're going to be covering today, hopefully. All right. So start by just walking you through Python basics generally. Then we'll cover two key parts. The first is syntax and structure, and the second is data structures. So under syntax and structure, I'll just show you how the Python language works, the things that set it apart and make it work, basically. So that'll be indentation, keywords, variables, data types. All right. Then we also have operators. We would cover control flow statements, and then hopefully functions and modules. All right. All of these are under syntax and structure of Python. And then finally, data structures, where I'll just run you quickly through some data structures. We might touch on lists, tuples, or dictionaries, and then I'll show you some operations that you can perform on these data structures. All right. So let's dive right in. So Python is one of the best programming languages. All right. Now, I don't say that just because I personally use and love Python myself. Again, if you've been taking the classes on the LMS as you should have seen the introductory video for Module 2, where you'd see me, give a little talk about what we're doing right now, basically. Right. So I am a programmer. I write code in Python. All right. I've been doing that for a little while now. Okay, so I do love Python, but I'm not saying that with bias. All right. If you take a poll, if you read around, if you do some research, you find that indeed Python is one of the best programming languages. All right, for a couple of reasons. All right. So the first reason that Python is one of the best languages is its simplicity. All right. When it comes to the syntax, the way the code is written and the way it looks, right, it's one of the languages that has the closest representations or arrangements to English language, right? Python is one of the easiest languages to read, so to speak, for a non-programmer or for someone who is not very versed in the language. All right. A very wonderful contrast to use here is R. Again, if you watch the introductory video, you would have seen that I did a little comparison between Python and R. All right. So R code is very complex. Now, I am a programmer. I've been writing code for over a decade now, right? And personally or frankly, I'll tell you that I don't really understand R syntax. Now, I do not know the language R, right? So that makes me a perfect candidate to say this. So just looking at the code in R, it's usually hard for me to tell what's going on because the structure is very complex as opposed to Python, right? Even for someone who has not written any code in Python, all right, but knows a little bit of programming it, you find it easier. They will find it easier to follow up on with Python by just like scanning through the code because it is, like I said, more human readable, one of the closest to regular human language like English, right, in terms of syntax. So before I dive a little deeper, let me just give a little quick run through, right? So the idea now is that a computer, generally, you can think of a computer as a machine, a robot, a messenger, right? It's something that just carries out instructions. So you tell it, do this, and that, and it goes ahead and carries them out, right? So that's what computers do at their core, all right? So it usually boils down to mathematics, like addition, subtractions, divisions, and at the basic form, it's even working in the binary system, like ones and zeros. Now, this stuff you may or may not have heard before, right? I'm just trying to give a quick run through to get to where we need to be today. All right. So when you think about it in that sense, it's easier to understand what programming is about, right? Programming, as a programmer, writing code, all right, is just basically writing an instruction set. It's called an algorithm, right? It's just writing an algorithm, creating a couple of steps or rules that allow the computer to perform a specific action or set of actions, usually like for a user, right? So the user could be you. You could write code that you use by yourself, or you could write code that other people use. A very simple example right now is where we are. So depending on where you are watching this or where you join from, you're probably on Jitsi, on the Jitsi platform in your browser, or maybe you got a mobile app, good for you. Or you might be watching this on YouTube, in which case you're probably, once again, also in your browser or in an app. So the point is that somebody, some people actually, it was not one person, a group of people wrote down specific instructions, right, that allow Jitsi to work this way, that allow YouTube to work this way, all right? That's why when you type a link in your browser, it takes you to a particular page, you click on the button, and the video plays, you press on that button, it pauses. This is for YouTube, by the way. Here on Jitsi, you could share your screen like I'm doing right now. You could mute or unmute your mic. These are just actions that are carried out, right, by a user based on the instructions, the code that the creators of the app or the software puts together. All right. So that's like it in a nutshell. That's really what programming is about. It's just basically creating an instruction set, rules that guide particular action. So one of the easiest comparisons or analogies that I have found so far is cooking, right? So yeah, it's fine if you don't know how to cook. Don't worry about it. But I expect that at a theoretical level, you understand the way cooking works, right? So to make food, to make any kind of dish, right, you usually have a recipe. All right. So let me use something more generic. Bread. Bread is, by the way, the most popular food in the world. Apparently, if you Google it, right, bread is the most popular food in the world. It's the food consumed most widely by people of all ages, races, even like social status. Bread is the most popular, most common food in the world. So let's talk about bread. How is bread made, right? So to make bread, you have to follow like specific instructions. Now, of course, there are places where you could deviate a little bit, right? But if you want to make bread, there are some very specific steps. So let me even make this interesting. So let's, since this is an AI course, right? Let me go to ChatGPT, all right? And let's just ask ChatGPT how to make bread. And you see it give us some simple steps that we can follow. So let me, let's share this quickly. All right. So I'd like to believe you can see my screen. You can see ChatGPT. So I'll just tell ChatGPT, tell me how to make bread in a few simple steps. All right. So when you want to make bread, there are a couple of things that you need. First of all, right? Like I said, we're looking at right now the recipe, how to make bread. All right. So if you want to make bread, you need some key ingredients, right? ChatGPT has listed these for us. Number one, ingredients. Then number two is to activate the yeast. Number three, number four, number five, number six, and so on and so forth, right? So now, if you want to make bread, the first thing you need, of course, is flour or flour, depending on how you pronounce that. All right. So if you want to make bread, you need flour, you need some rising agent. You could use yeast, maybe baking powder. I don't know if baking powder works. You need some rising agent, and you need maybe sugar, salt, just something to give it some taste, and so on and so forth. So if you want to make bread and you don't have flour, right? If you have, I don't know, let me say, okay, another popular food is rice. Rice is also very popular around the world. So regardless of where you're watching this from, I expect you know rice also, right? So if you want to make bread and you did not have flour, but you chose to use, but you have rice and you chose to use that instead. Now, as long as you follow these same key steps, I promise you that's the rest of the steps from, okay, right now, ChatGPT gave us 7 points. Okay, 8 points. ChatGPT gave us 8 points, right? So as long as you follow these 8 points exactly, but simply substitute these first ingredients your flour for rice, right? You definitely end up with something different that would not exactly be bread, but I promise you that it would be close enough, right? Because the key to making bread is that you follow these steps. So even if you substitute some ingredients, as long as they are similar enough and you follow the exact same steps, you end up with a very similar result, right? So the concept here is, if on the other hand you use flour exactly as you're told to use flour, and you make this and you follow these steps, it doesn't matter what part of the world you're in, it doesn't matter what kind of oven you're using or what kind of water you have, as long as you follow these steps exactly, right? Even where they tell you the temperature. Let me see, where's the part where they say put it in the oven? There we go. So here's the part where they say put it in the oven, and they told you the temperature should be 190 degrees Celsius, excuse me, 190 degrees Celsius for 25 to 30 minutes, right? So they need to put the model of your oven here, right? It doesn't matter if it's a Benaton, a Samsung, or whatever. It doesn't matter who made your oven, right? As long as it's a proper oven for baking and you follow these instructions, you get the same results at the end of the day, bread, right? So as because this algorithm, this recipe has been put together, anybody anywhere in the world, regardless of your skill level, can make bread as long as you follow these instructions. So that's the same principle for programs, for writing code. When you write code, all right, as long as the platform is run on is compatible, like in this case, the example I gave was flour, like replacing flour with rice, or like the model of your oven being irrelevant, provided it's a proper oven for baking and you use this temperature for this amount of time, right? So as long as there's some compatibility, it doesn't matter. You would always get the same result. So programming is just that, creating simple steps, telling the computer to perform certain steps to get to a particular kind of result. All right. So now Python, like I said, is a very wonderful language because it allows you to do that in a simple and easy way. And even though at its core, Python is designed to be simple, Python can also perform some advanced tasks and can be used for all sorts of things, which is why it's also used for AI programming, right? So for machine learning and all of that. So we're not going to go deep into all of that today. No, we're just going to touch on the introductory part of it. So I'm just going to teach you Python itself first of all, and then hopefully you can build up on that to do more things. All right. So in order to use Python, you need to get the Python, you need to have the Python environment. So there are several ways to go about it, all right? You could install, you could download and install Python on your device. So if you are on a Windows PC, okay, if you're on a computer, right, be it a Windows PC, Linux, or Mac, you could go to the website, I believe it's python.com or python.org. I'm not sure, you can just Google it. Google is great for that, right? So if I just type Python in Google, right? I just see that, okay, it's .org. I wasn't sure. So if you go to python.org, look at downloads. If you go in there, you can pick the version you need for whatever platform you're using for your PC. If you're on the phone, there's also an app for it. So I don't know about iOS because I'm an Android guy, sorry. But on Android, there's an app called PyDroid, which, by the way, in my personal opinion and from my experience, is the greatest IDE for Python on Android. Now, IDE is integrated developer environments. It's just basically a system and application that lets you write code in a very intuitive and nice, fun way with some helpers and all of that. Yeah, so that's if you want to have the Python environment natively. But if you don't want to have it natively, if you don't need to go through all of that, I mean, we live in 2025, right? A lot of things are web-based. There are web-based options, right? So I will not take too long on that. I'll just tell you that one of the best options you have for that is Jupyter Labs, right? So they have this thing called, okay, let me walk you through this the same way I did that. So I'll just share that tab to show you what I'm talking about. All right. So it's Jupyter. It's spelled Python like Python, right? So this is like a play on Python, right? It's, you can think of it like that, right? So it's not like Jupyter the planet. It's just a mix on, yeah, play on that. Yeah. So if you search for Jupyter Notebook, you find that, right? And then if you click that's Jupyter.org or Jupyter.org, however you want to pronounce that. And if you click on this or go to Jupyter.org/try, you get to this nice page. And if you scroll down, you see these two options. So you can pick it out of these. They give you basically the same thing. So let me just pick the first one, which is Jupyter Lab. So when you do this, right, it gives you a Python environment in your browser. So in this case, you don't need to install anything. And one of the advantages of this is that it's easier to run this on a mobile device, like say a phone or a tablet, right? Because in that case, it doesn't matter as much how powerful or capable or whatever your mobile device is, right? Because it's running in a browser as opposed to natively on your device. So right now, this is what I'm going to use for like what we're going to do today. All right. So yeah, let's dive right in. So the first thing we're going to touch on here is um, the Python syntax and structure, like I said earlier, what Python looks like. So to get started, I'll just create a new one. There's this plus. No, not that. There's this plus over here. Yeah, there's this plus. I'll just okay. Yeah, it's the same button, and then I'll just choose Python file down here. Just choose that. Oh no, not file. Yeah, I actually wanted a notebook. Sorry, my bad. So I'll choose this first one. Sorry. Yeah, this is what I want. So the advantage of using a Python notebook instead of a Python file is that you can run it in here and get your results in here. All right. So now let's talk about Python. What is Python? Right. So Python is a programming language that is very powerful and wonderful. Like I said, it can do so many things, including basic math. So right now, if I type 1+1, all right, and oh boy, I think keyboard shortcut shift enter. Yeah, shift enter. It gives us, it runs the code, and we see the answer is 2, right? So by default, Python is basically a calculator. You can say times 2 divided by 3 and run it, and it gives us the answer right there, easy peasy, no stress, no issue. And like I said, we're running this directly without even having to install anything, right? That's one of the beautiful things about using this Jupyter Lab. So Jupyter Lab is not the only option, right? You could use there's a Google version, there's the GitHub version. There are all sorts of versions of them, right? But this is just one I offered you. So feel free to explore other options. All right. Okay. So structure, what does it look like, right? So the first thing we have on that structure is okay. Just a second. Let me see if I can put this here for you. All right. Just 1 second. All right, so just want this to be kind of here so you can kind of see it. Say, hey, all right. Okay, let me make this bigger because there it's so tiny. Zoom this a bit more so you can see it better. All right. Okay. So this is 1A. This is 1B. This is 1C, and this is 1D. All right, so let's start with this. Okay. So I'm just gonna, yep. All right. So I didn't run this code, by the way, which is very important because if I run this, it's give me an error, which I'll get in a minute. So now let's start with 1A. All right. So to run Python code, you just type whatever you need it to do, right? So there are several keywords, all right, that are reserved for Python program. So there are several of them. They perform all sorts of functions, all right. So there is print, there is, sorry, excuse me. There are sorts of words that are reserved for the platform, right, that you cannot use for anything else. That's what those are. So there are a whole lot of them, right? And they are designed as English words to make it easy for you to understand what they do. Here's an example. Okay, I said print earlier, so let me show you print. So okay, let me take this from a different direction because this might confuse you. So there are several words like that that do a lot of things. So there's like and, there's def for creating a function, there's while, there's if, else, there's all sorts of keywords, right? But I won't take it from that angle because this can get confusing pretty fast. So instead, let me just take you right into the meat of Python, show you what Python does, and then along the way, as I'm showing you stuff, I'll tell you what they are, right? I think that would be a better way to go about this. Okay, so let's just print something. So, like I told you initially, Python by default is a calculator. So if you type anything, it assumes that it is of different data types. I have to jump to data types now. I'm on data types, right? So whatever you type by default is assumed to be one of these things: a keyword, a variable. Let me check this out. It's going to be a keyword, a variable, or some kind of data type, right? So if I typed 1+1, for instance, so this one is of a data type integer, right? And oh, yep. So if I wanted to print that, I can just do 1+1. Okay, that's true. I don't need to put print here. I can just do 1+1. Cool. And it gives me 2, right? But what if I want to use put like a name, for instance? So a name is thought of to be a string. All right. A string is just any kind of data type, like letters, numbers, etc., that do not need to be directly computed like in arithmetics. Like when I type 1+1, right, it does 1+1. But if it's a string, it knows that okay, this has special characters, and strings are denoted with quotes. So in Python, you can use double quotes to type your name, for instance, or you can use single quotes. They work exactly the same. There is actually no difference between the two in Python. So for some other languages, double quotes means something different versus single quotes. But in Python, Python is just trying to be easy. Python is trying to stress you, right? So in Python, both work just fine. Okay. So since I'm using Jupyter Notebook, I don't actually need a keyword. So if I just do this, should print my name, done other jobs. All right. So walking through data types, there are different types of data, right? So you already know, I expect, that data is just any kind of like fact or quantity, is a collection of like a discrete value that you can use for something, right? So if we're looking at data types, oops, if we're looking at data types right now, let me just walk through what we have here. So data types, we have integers. So integers are basically whole numbers. So 1, 1,000, 32. Okay, I typed 43. Sorry, 43. Just any whole number that doesn't have a decimal point. That is what. Okay, let me make this easier for myself. I just okay, good. All right. So data types, we have integers. We have floats. So a float is a number, but unlike your integers, it has a decimal place. So 0.1, 23.2332, whatever. Just any number basically that has a decimal place is called a float or floating point number, if you like. That's when we look at that. Then you have booleans also. So booleans are basically true or false. That's true, false, period. Like they're just there's true or false. There's nothing else. So interestingly, because booleans only have two parts, and so does binary 0 and 1, you can also think of boolean to be binary, where 1 is true, 0 is false, or something like that. All right. So yeah. And of course, okay, I didn't put the first one. We have strings, which is just basically like your name, Donald, or AAN, or Python, right? Yep. So these are basic data types that you can work with. All right. So I just want to show you something cool, something interesting about the way this works. So if we take the first one, string, I already showed you what that looks like, right? So if you put two strings together and put a plus, it just joins them together like so. And note that there's a space in between this and this because I added a space here, right? If you remove that, you just get them as is because it just joins them blindly. So if you want a space, you literally have to add this space by yourself using this method. But there's something interesting though. If you use the print command instead, you don't have to because this one automatically adds spaces. So I still get the same. I left the space. Notice how there are two spaces now because I forgot to remove that space. You still get the same result now with just one space in there. So that's something interesting to bear in mind, by the way. So that's for that. And then integers, I can say 1 plus. I'm just using the examples I typed earlier. If I say 1 plus 1000 and run this. By the way, I'm running it to shift enter, right? But if you're on the phone or on some device where you cannot easily use like keyboard shortcuts, there's a play button up here. All right. So if you press the play button, it also runs that for you, by the way. In case you can't press shift enter or you forget, that's fine. Just hit the play button. All right. And note that I have these in separate cells, right? Cells just allow you to organize your code properly, right? So you can separate them and but still work with them together, which is a cool feature that this has. All right. So moving on. So this is strings, this is integer, and floats, and so on and so forth. So you'll notice also that there are certain operations that you obviously cannot perform on a string, which is what makes strings special, right? So for this now, I can change this to a division sign, which is the forward slash, and it divides that and gives us that answer, which is a float. But if on the other hand, I went back to this thing I had here, this string, and I change this to that, oops, sorry, and I change this to that and run it, then it gives us an error because you can't divide string. That is an unsupported operand. All right. So that's just something to bear in mind. The fact that Python lets you perform some basic operations with operands like plus and so with strings as it does with other values doesn't mean it can perform everything. It's just a simple way of doing it. All right. So the difference to note here is that when you use the plus sign for strings, it's called a concatenation, not an addition. All right. Whereas when you use it for these other data types here, like integers and floats, it is then an addition. Interesting, I can do that. It's an addition. So it's the same symbol, right? But they perform different functions. Just something to bear in mind. Okay. So that is for data types, right? And that also to some extent covers operators. Like I said, I want to just start showing you stuff and then I'll tell you what they are. Because if I want to take this one after the other this way, to just get confusing fast. So already you've seen arithmetic operators, right? So the next thing that we'll touch on, is comparison. All right. So comparison operators are basically what can I call these? Okay. So for comparison operators, this is one. Okay, let me just create a name so and just copy this down here. Okay. All right. So I've shown you arithmetic operators, plus, minus, etc. So now let's go to comparison. All right. So for comparison, you can think of greater than, less than, greater than, equals, stuff like that. Then there's also not equal. There's a couple of them. All right. So I won't go through everything. I'll just show you basic ones. So note that when you perform comparison operators, it gives you a Boolean response. That's like true or false, 0 or 1 as your response, right? So it's just basically, you're just basically asking it, is this whatever your operator is than that? So let's take the first one, greater. So I say 12 greater 11. So I'm basically asking it, is 12 greater than 11, right? And yeah, true. 12 is greater than, like I said, you get true or false. It's a Boolean kind of operation. So you get true or false. If it is not, like say I make this 19, then you get a false. And of course, it works the other way. So is 12 greater than 19 false, means 12 is less than. So if you get false here and I switch this to the other, which is less than, and obviously that, right? Then sometimes you want to check equality as well. So this equal that. Now, of course, typing 12 and 19 here seems dumb, right? Because obviously we can see that 12 is not equal to 19, right? Which will take us to the next thing I want to show you, which is variables, right? So while you're working in life, basically, not just in programming, it's always good when things have names, right? Because that's why we have like nouns and pronouns. When things don't have names, when things don't have identifiers that you can call them with, it becomes difficult to reference things or refer to them. For instance, look at where we are right now. We're in Jupyter Lab. What if when I wanted to come here, this thing didn't have a name? What would I call it? I'll say that thing that has boxes and cells, right? So they gave it a name, which is Jupyter Lab. right? So when I say Jupyter Lab now, we know this is what I'm talking about. The language we're working with, Python, it has a name, Python. So that when we want to refer to it, we just say Python. We don't say that thing, that language. And then people are like, which language? There are like tens of programming languages, right? So that's why generally things are given names, identifiers, so that you can refer to them later. You can refer to them over and over again without having to start explaining and establishing what the thing is each time. So when you're writing code, when you're programming, right, the same thing applies so that you can always refer to things without always having, well, the word is declare them. So let me just show you a simple example of that. So right now, come down here to variables. All right, so this is variables. So I can just do something simple like, okay, so variables are defined with words, just a simple word, and use an equal sign, and then you put what the thing is. All right, so here's an example: name equals, and then you type whatever you want. So it's a string, right? Meaning it's not a number. So you always have to put strings in quotes. Very important. You always have to put string in quotes. Once again, like I said earlier, it could be double quotes or single quotes. It doesn't really matter. As long as it's a quotes, that's all that matters. And you have to open and close it. So use two. So right now, name equals Donald, right? That's my name, right? And okay, let me make this interesting. So first underscore name equals Donald, right? And last underscore name equals, well, my last name. So let me use single quotes here again. Now, you shouldn't do this, right? For the record, for future reference, when you are writing code in Python, try to stick to one type of quotes. So here I'm using double quotes here and single quotes here, but only to show you that both work. All right. When you're writing your code, please pick one and stick to it. Okay. So either you use quotes or single quotes, but please do not have your code look messy with single and double quotes all around. And note that you cannot mix them either. So if I use a double quote here and a single quote there, that will give an error because, like I said, you have to use both. You have to use two. So when you open your double quotes here, you have to close your double quotes here. Very important. So I'm using single quotes here. Open, I have to close also. All right. So I've defined these two things now. So if at any point in time I call any one of them, like I say first name, all right. Oh, sorry, shift enter. It's going to print my first name, right? If I change it to last name, it's going to print my last name. But that's because I've defined these two, right? So if I ask for something I've not defined, like say middle name, it's give me an error, right? Saying name, middle name is not defined because I've defined them. So this is how you declare and define stuff, right, in Python. Keyword equals and whatever the value is. So note that the first character here must be a string, but after that you can use like one, you can use some funny things. But Python is designed once again to be simple and easy to read. So something called the Zen of Python. I won't get into that right now. I'll just type it in the corner in case you want to go look it up by yourself later on. So it's called the Zen of Python. It's just basically like a poem. It's the principle, all right, of Python. It's the core values, if you like, of Python, like how Python is designed to be a simple language and all of that. So if you read about the Zen of Python, it could help you with writing like good, proper, professional looking, clear code in Python, right? So one of the things you learn from the Zen of Python is that you should make variable names easy to understand, right? So right now, I called this first under name. I could have called it anything like Ben. I could have called this ZZ23 and they will still work, right? If I put Ben and ZZ23 and run this, it prints. Oh, yeah, it only prints the last name. Okay, so I'll have to maybe do this. Yeah. It prints both. Okay, space. Sorry, after the space, so I'll just do that like that. Yeah. So it still prints both quite all right. But then what is Ben and what is ZZ23? These are things I can easily forget. And these are things that if I or someone else comes to read my code later, they can easily get confused about, right? So it's very important that when you're declaring variables in Python, you name them something proper, something that makes sense. So that when you see it, you already have an idea of the function it performs, right? And it's easy to remember it later when you want to call it. Because remember, you declare variables so that you can call them, you can use them later. All right. So okay, I already showed you what I was just trying to do now. Oops. Which was to print both names. So if I say first name, let's put a space in between, last name, something like that, and it prints my name. So this is exactly the same thing as what I did here, right? Except that here I typed it manually, and so this was fixed to get this. So what's the advantage of using variables, right? Is that you can do other things with it. So here's a simple greeting, for instance, that you can do. So I could say print hello, comma, first name space last. What just happened? Sorry, I did something wrong. Last name. So remember, I told you earlier when you use print, all right, that goes with comma, not a plus. It automatically adds a space for you between these. So right now, I don't need to do this plus quotes with space in between things to add a space. So hello, this. Okay, I used single quotes earlier. Sorry. Welcome to today's LLS. Okay, this is something I thought I'll show you later, but I have to show you now. Okay. Just use double quotes here because of the apostrophe. All right, so hello, first name, last name. Welcome to today's LLS. All right, so delete that line and run it. So now I have hello, this, welcome. Let me make this look even better by doing that. Right, okay, that would not work here. Let me just leave it that way. Hello, this, welcome to that. There's stuff I can do, but I don't want to make this complex. So let me just leave it this way. So, hello, Donna Dajabs, welcome to this live learning session. Yay. So because I use variable names here, if I wanted to change the name that I have here, all right, all I have to do now is change the values of those variables, and that's done automatically. So let me see, 1 second. I just want to get some of you guys' names to use for this. So like I already have my name in here, so I want to try a different name, someone else's name. All right, so I see in the chats someone named, not in the chat, in the participants, someone named AAN. So I just put that here, and let's see, Williams. So if I run this now, those get substituted automatically. So what makes this lovely is that I can reference first name and last name much later, and it still gives me these same values. I wouldn't always have to type that, right? So to let me still leave that there. All right, and I can put something like this. Okay, and add some more stuff like you are a and nationality. I made a mistake. I didn't spell this properly. Nationality. All right. So now, hello, blah blah blah. You are Nigerian. Boom. I added a space here. Sorry. So that's how variables work, right? You declare them once, and then you can reuse them over and over again whenever you need them. All right. So comparison. Okay, yeah. Okay. So I remember why I came to show you variables is I wanted to show you comparison operators. So I was saying that if we just say 12 equals 19, then of course that's silly, right? Because we can by default, even with our eyes, see that these two things are not the same. So where this becomes very useful is when you have, say, variables declared, right? So let's say, for instance, start. So this class started 1 p.m. West African time. So I'll just say start equals 1 and is supposed to be in 10 minutes, by the way. And is 2 p.m. West African, right? So in this case, we do not know, or we might not necessarily know what is in here or what is in here. So if we wanted to find out, we can just say, and would a comma work? I don't think so. We can just say, and this is where print comes in. I want to print both of them at once. Prints starts and now you see what did I do wrong? And starts blah 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 blah. Name starts is not defined. Oh right, I have to run this first. Sorry, and now run this. Sorry. Yeah, that's something to bear in mind, by the way. Good thing I had that error. So I typed these new lines in this cell, but I did not run it. Because I did not run it, the Python processor had not seen them, so it did not know what these were. until I came to run this cell. So it's very important. I told you one of the advantages of using cell is that you can break your code up, right? But note that if you are referencing something in a previous cell from the current cell, you need to make sure that you've run the previous cell first of all in this session, right? Otherwise, this does not know what's in here until it has been run. All right. So yeah. So now I can ask it. Okay. So now is the start greater than the end? And this is now a comparison that makes more sense because we cannot automatically see this here probably, right? So where this could be even more useful is if, for instance, I say, all right, let's use pretend ages. So let's say first name person. No, let me leave that. Oops, destroy that. Let me create more variables here. So I'll say person one is me. All right. And let's say age one. Of course, this is not my real age. I'm just using a random number here. Let's say 12. Then person two is this other name that I keep coming back to. And age of person two is, I don't know, 15. All right. So we can do something interesting like, okay, if we want to know who's older between the two of them, we can just say age one greater than age two. Sorry, shift enter. And it says false. Okay, that means person two is older than person one. All right. So, or actually, no, it doesn't mean person two is older than greater than person one. Sorry, I lost something I'm trying to find. Okay. So if I run this now, I'm asking it, is this the age of the first person greater than the age of the second person? It says no. So that means that it is either less than or equals to that. Because by the way, this will still give the same thing if it's 12, right? Because 12 is not greater than 12. 12 is equal to 12. So that's something very important when using comparison operators, by the way. You have to know to ask the question right, depending on what answer you are looking for, right? So in this case, if we say greater than equal, then it says true, meaning it is either greater than or is either equal. And then it matters how that goes. So just basically structure this the way you need to. All right. So let's see. What's the next thing we have here? We have logical operators, which are similar, actually, but they just use English words instead. So the logical operators are stuff like and, or, not, etc. But I'll just leave those for now. I'll get back to them shortly. Like I said, I'm trying to do this in a structured format so it makes sense and it's not all random. So instead, I'll get to control flow statements. And it's in control flow statements that I'll use some logical operators because that's when they'll really make sense. Just like it doesn't really make sense. Same thing with the comparison. It doesn't really make sense yet. It's not really useful until we begin to do stuff with it with control flow statements. All right. So let's get back to this program now and get into, let me just copy and paste that so you can see where we are. And let's get into control flow statements right now. Let's get into control flow statements. All right, so control flow statements. So I've defined these two people, right? Person one, person two. All right. So let's do some comparison here that makes sense. So the first thing we'll touch on is if and else. So think of if just like it is in real life. So if is conditional, right? Is a declaration of an action based on certain conditions. So if this is this, then do that, right? So the one of the examples I gave earlier was about making bread, right? So I said if you want to make bread, you need ingredients, and one of the core ingredients for bread is flour, right? So you can think of a control flow statement here as if I have flour, then I'll make bread. Else I would make, I don't know, something else. Once again, in the previous example, I had rice, right? Instead of flour for my bread. So if I have flour, I'll make bread. Else, right? That was if. And now else, I would make something else with rice. I don't know. So maybe tofu. I think there's some tofu with rice. There's, oh, okay, I'm in Nigerian, right? And we're always battling with Ghana. So let's say I could make some jollof rice, right? Since I have rice. So I could make some wonderful, delicious Nigerian jollof rice, right? But if I do have flour, then I would make bread instead. Else, I'll make some jollof rice. So that's just the way that works. Like I said, this is created to be analogous to English language, makes it easy for you to understand. So let me give you a simple example here. Right now, we have these two people defined here. I want to know like who's older, or let's say want to assign something to the older one and something else to the younger one. So I don't know what to assign. Let me just print their name. Let's say this is a data analysis thing. I want to know the order between these two people. So in Python, you declare an if statement that just type in if. Note that it's case sensitive. I don't know why I typed capital F. Note that it's case sensitive. So it's small letter IF. I'm used to typing in English. I'm sorry. So I typed capital F stuff small. So if then you put your condition, and your condition will typically have an operator, either this or that, right? So I don't use comparison. So if age 1 greater than age 2, remember this is what we did earlier, but then it just printed false or true, which was not very useful, right? So now we'll use an if statement in combination with our logic, with our comparison operator to do something useful with the code. So if age 1 is greater than age 2, so in Python, you define what you want here. You put the if statements, you put the condition, this is the condition, and then you put a colon. A colon has 2 dots, right? You put a colon, and then you press enter to go to a new line, and make sure you have this space here, right? Notice that I'm no longer at the beginning here. I'm here in the middle. I'll explain why shortly, but let me just finish. So if this is greater than this, then print if age 1 is greater, that means whoever owns this age is older, right? So I'll just say print. Remember, put it in brackets, no space, by the way, between the T and the open brackets. Sorry, I keep typing like I'm typing English. I'm so sorry. So print, open, close brackets. All right. And okay, so say person one, comma, is older. That's all. Oops, what did I just do? Say person 1 is older. Else, same thing, but this time person 2 is older. All right, and that's it. So now, just to walk over what we just did, if then we use a comparison operator, age 1 greater than age 2. So it checks, is this age greater than this age? If it is true, if age 1 is indeed greater than age 2, it does whatever we have here. Note that that's why we have this space here. This part is indented here. So we've told it that, oh my God, we've told it that it should perform everything that is in here. And I said everything because I have only one line, but we could have multiple lines. We could have other statements going on here, right? We could have other things going on. So it just checks after this colon for everything that is indented, everything that is shifted forward like this, so to speak, right? And that's usually 4 spaces. 1, 2, 3, 4 in Python. That's like the standard. 1, 2, 3, 4. You can use less if I'm not mistaken. I'm not 100% sure of that. But the standard is used 4 spaces. And like I told you earlier, the Zen of Python says that you should keep things structured, right? So the structure is 4. Everybody uses 4. So please use 4. 4 might not, using 2 might work, but for everyone uses 4. So even I just use 4. So please use 4 spaces, all right, to indent, right? So once you do this, it tells it that, okay, everything in here is a block. Okay, let me just type it properly. A code block. So this entire area in here is called a code block. And in here is another block. So here is block 1, and here's block 2. This is tied to the else statement, excuse me. And this is tied to this parent if statement, right? So it checks this. And if this is true, it does everything that we have in here. It runs all these lines of code. It performs these instructions. But if it is false, right, it will perform these instructions here instead. Okay, so let's run that now and see what we get. So obviously we already know that because we can see it here live, right? We know that age 1 is not greater than age 2. Therefore, it should do this one instead and say that person 2, which is this AAN, is older. So let's just run that. And it says that, of course, this is older. So if we do it the other way and switch the ages, for instance, let's make me older than the other person. Now we say, of course, that Donald is older. So you can now see that once you start putting all these little things together, all right, the building blocks, all these tiny things that have been walking you through separately. Once you start putting them together, you can begin to create an actual structure, an actual instruction set, an algorithm, if you like, or recipe that does something that makes sense, right? Because in the previous example we gave about making bread, if you have just flour or you have just sugar, well, that's all well and good. Those are just ingredients. They don't really do anything on their own. But when you begin to mix them together and put it in the oven, like apply heat to it and all of that, when you basically follow the recipe, when you bring them together in a particular way, you get something different. You have your raw materials that you start with, your ingredients, and then you end up with a meal with something that can be eaten, right, at the end of the day. So writing code works the same way. You have the building blocks, which is what I'm walking you through today with the Python syntax and structure. And then when you put these things together, you can write code that can perform all sorts of functions for you. All right. So one other thing I would like to just touch on here quickly is this part I deleted here, which was indentation, because like I said, I was going to confuse you at the initial point. So indentation is what I just showed you here, these four spaces here. So in Python, you declare a code block by indenting. Once you shift these in, these are now automatically under this. But note that it is always prefaced or prefixed by a colon. All right. So you cannot just randomly declare a code block anywhere. So there are certain conditions in which you can declare a code block. So one of them is your control flow statements, if, else, for, while. Another is when you're defining a function, right? So I don't know if I said it earlier. Did I type it? Yeah, I didn't type it. But when I was, or if I did, I deleted it. When I was talking about keywords, one of the ones I talked about is def. So you can use def to define a function. Let me just type it down here so I can delete this. You can use def to define a function. You can call it whatever I like, some function. And then when you do that, you indent this and then type whatever you want there. And now we have this function named that. Now we've not gotten to functions, so I'm not trying to really show you what a function is. I'm just trying to show you another instance where you can define a code block. So now I've defined this block here. Everything here runs under this. Once this is called, it performs all these tasks here. The same way, once this enumerates as true, it performs everything else here. Else or otherwise, it performs everything else here. So that's basically indentation. That's how indentation works. And indentation is very important in Python because, for instance, over here, without indentation, we cannot use this if-else statement, right? So indentation is a very powerful part of Python, all right? So let's see, what can I wrap up with? So I would like to wrap up now. So let me see, what can I wrap up with? Okay, so I've shown you these, Donald is older, blah, 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 blah. All right. Okay, I do have functions here. So, okay, let me even show you how a function works. All right, so let me just quickly show you how functions work. So to declare a function, you just type def, like define, I guess, to define a function. So you can call it whatever you like. So in this case, let's see. What simple function can I do now? Okay. Let me convert this whole thing I did here into a function, right? Oldest. Okay, let me make it funny. Who is older is the name of my function. Now, note that when you're defining keywords and variables and function names and such, you can't use spaces. Because if you use space, if you include a space, then it assumes that this is separate from this. So if you want to include spaces, so to speak, in your variable names, function names, etc., you'll need to use an underscore. Another way to go about it is capitalization, kind of like you do with hashtags. So you can do WHO, lowercase, I, uppercase, small s, everything else. Then for each new word, you could capitalize the first letter, right? But this works, by the way. So who is older this way would also work. But note that, again, this is frowned upon generally in Python, right? This is generally the way it's done in Python with underscore. So you can do this or this. They will both work. But once again, this is the industry standard. This is what most people expect. But of course, you're free to do it the other way. It's just my job to tell you both. All right. So now who is older? So I want to make this a function. Aha. Which reminds me of parameters. So when you define a function, you have to open and close the brackets. and in here you can define parameters. Now I'll explain those later, but right now what I want to do is just type everything and then explain what I'm typing. So notice that I'm just typing the same keywords from earlier. Person 1, person 2, age 1, age 2. I'm just typing those same things out again. So age 1, age 2. All right. And we'll actually have the exact same logic. So, okay, let me just type it, stop copying and pasting. So once again, if age 1 is greater than age 2, and notice that we can do this in any order, right? So for instance, I can use a different comparison operator and say if this is less than that, and then flip the logic. All right, sorry, for some reason the streaming to YouTube stopped, so I had to go fix that. I don't know why that happened. All right, so we're back up on YouTube. Okay, so yeah, where was I? So I was saying I want to flip the logic because that's the idea of this thing. There isn't one way to do it. There are different ways to go about it. So you can choose whichever works best for you. So here I used age 1 greater than age 2, right? But something I can do is flip it and say if age 1 is less than age 2, right? So if this is less, that means that automatically age 2 is older. So that's what I'll print here this time, right? So I'll say person 2 instead of person 1 this time since we flipped the logic, right? But I just typed it. Sorry about that. He's older. All right. And then we say else. Note that the if and else should be on the same line with your indentation. Now, there are some things that are fixed for you automatically, but in case it's not fixed for you automatically, just make sure they're on the same line. Your else should not be in here, right? It should be on the same line with the if because it's defining a different code block on this level, right? All right. So else, we're just going to print the opposite. Person 1 is older. All right. So we can do this. All right. And now to call the function, you just type its name. So the same way we did prints earlier, open and close brackets, right? If you want to use this as a function we defined, you just type it who is older and then open and close that. All right. And now we have to pass these parameters, these things in the same way we created the same order rather that we are defined here. So that means what this function needs now to work is the first person, the second person, the first person's age, and the second person's age. So to do that quickly, I'll just type new names this time. So I think I had Williams. Sorry, excuse me, Williams. And I think I had a Jane somewhere and Jane. So these are two people's names we're checking. So their ages will be whatever, like we can say 23 and I guess 22. And if we run this now, okay, I didn't do something properly somewhere. Who is older is not defined. Oh, right. I did not run this cell again. I can't believe I did that again. Sorry, guys. So I did not run this cell. Therefore, it doesn't know what who is older is. Remember, I told you that earlier. You have to run the previous cell. So when I run this though, we won't get any outputs because I didn't tell this to output anything on its own. But now I can run this and it works fine. So it says Williams is older. Easy peasy. I can call this whatever else I want. I can say James and Jane, maybe, and James is still older because, you know, this is this and that is that. So note now that because I'm defining the function here, once again, we can call this whatever we want. So for instance, I can call this name 1 and name 2. I just choose to call it the same person thing so you don't get confused. But it's literally the same thing because all these names, yeah, they're actually called names or variables, were defined by me. Therefore, I can call them whatever I want. All right. Then now let me show you another way to also flip this logic again slightly. Right. So I can use my comparison operator to simply get the name of who is older, right? So let me show you what that looks like. And I wouldn't have to print in the if, oops, sorry. I don't have to print in the if statement. I can just define a new one here and say, if this is less, if this is that, then I'll define a new variable here called older. Older equals 2 else older equals name 1. Again, I'm just trying to show you different ways to accomplish the same task, right? You get the exact same results, but just in a slightly different way. All right. So in this case now, instead of printing the results from the if statement, right, I'm simply using this to get who is older. And where that becomes interesting is here. Okay, let me run this first. Okay, if I show you that, let me run this first. So right now I've changed the logic, and all this does is it sets the name of whoever is older as this variable name named older. Then at the end, it now prints that as older is older. So again, I have to run this, remember? I have to run this, and then when I run this again, it gives me the exact same thing. It's like nothing has changed, right? Of course, nothing has changed because the logic is still the same. I just changed the way it looks. All right, so now here's something interesting you can do with functions. Instead of printing from here, a function can return a value. To return means to send it back so that whatever calls the function receives this thing. So here's what that looks like in practice. Now I can, let me type this separately. I can say print, like let's say I want to know who is older. Print. Now I can say older equals who. Okay, you know what? Let me not type this whole thing so I don't waste time. I'm trying to wrap up. So I'll just come here and say older. Okay, fine. Let me say oldest. So it doesn't look like it's the exact same word. It doesn't confuse you. Oldest is equal to this. And then prints oldest is older. No. Okay, let me even change it and say is the oldest, I guess. All right. So again, I've edited this. Notice that orange dots over here. That tells you you've edited it, right? It's like a warning telling you need to run this so it's in the memory. So if I run this now, I get James is the oldest. So what's the advantage of going through this means? Well, I'll tell you. The advantage of going through this means is that this function is called who is older, right? So earlier, when I had it print the results as James is the oldest, that was finite. So what if we wanted to use that name for something else? What if we didn't want to say is the oldest? Sorry, is older, like we have here. We don't say Donald is older. We want to say James is the oldest, or perhaps even reformat it and say something like James, you are older, or just use it for something else. That's the advantage of using a return value. So here what happens is that this function checks for who is older and simply returns the name. So when you get the name, you can then use the name for anything else you want instead of having it just be fixed as this simply printing out the name. So there you go. That is basically Python syntax and structure in a nutshell. Now, there's a whole lot more to it than this, but with these, you can get started on writing all sorts of programs that can perform basic functions. And when you chain these things together, you get some even more advanced functions. Yeah. So that's where I'll stop for now. So I've been going through the chat and I've not seen any questions, but I'm just going to ask now. Does anyone have any questions, please, before I wrap up? All right then. Thank you very much. So far there are no questions. So this is where I would end class for today. So of course, feel free to reach out to me or to any of the other staff in the dedicated channel on Discord, Cohort 1, or in the WhatsApp community, also named Cohort 1. So that will be all for today. Thank you very much. And join us again same time next week, Saturday. And happy coding, learners. God bless you.